Hello everyone. Audible.
Yes, ma'am.
So this is your week seven doubt session. So you can ask your doubts. Week seven. We can start with activity questions first. So from activity 7.1, anyone has any doubt? Any questions on this activity? Okay, then from 7.2, any question? From any other activity? Any other question? Please say if you have any doubt. From any other activity, you have any doubt? Any question from this week?
Ma'am, I have a doubt in practice assignment.
Okay. Practice assignment one or two? 7.1 or 7.2?
7.2.
Okay. Which question? So for practice assignment, solutions are given. So did you check the solution first?
No, ma'am.
So you can see for practice assignments, solutions are already given. So which question do you want to ask?
Five question.
Question number
Fifth.
5. Okay. This question. Yeah. So for question number 5, this is the information given. Okay. So the question is 90 students have participated in the annual cultural festival of a college comprising of singing, dancing, acting competition. Okay, so the number of students who did not participate in the acting or dancing competitions are 10. The number of students who participated only in the dancing competitions are 15. The total number of students who participated in the acting competition are 50, and the number of students who participated in both the singing and acting competition are 20. And number of students who participated in the both dancing and acting are 15. And the student who participated in all the three competitions are 10. So based on this information, you can make the Venn diagram first. Okay, and then from the help of Venn diagram, you can answer the following questions. So the question number 5 is, what is the probability that a student selected at random has participated in both singing and acting competition, but not participated in the dancing competition? So let's make the Venn diagram first. Okay, so you can see that three things are there: singing, dancing, and acting. Okay, so So suppose this is the circle for dancing, this is for acting, and this is for singing. Now, let's see first what information given to us. So, first line is the number of students who did not participate in acting or dancing. Competitions are 10. Okay. So, they are not participating in the acting or dancing are 10. Okay. So, which means this part.
Yeah, the A union D
A
complement, right?
union D complement.
Yeah. So, they are not participating in the dancing and acting. Okay. So, this will be that reason, right? Uh, this reason. Okay. So, this is given as 10. Now, we have to see other things. Next, we are given the number of students who participated only in the dancing competitions are 15. So only in the dancing, 15. So this will be that reason. Okay, because this reason that will contain the intersection part for DNS, dancing and singing. Okay, this entire and this entire part will contain dancing and acting. So we just have to remove this part. Okay, so here we have 50 number of students who are only participating in dancing. Okay, from the next line, the total number of students who participated in acting competitions are 50. So total for acting is 50. So for acting, total is 50. I'm writing it outside for a minute. Then the number of students who participate in both singing and acting are 20. So both singing and acting, which means singing and acting. So this entire reason, right? So this entire is 20. Okay. Now see other information also. The number of students who participate in both dancing and acting are 15. Both dancing and acting. Both dancing and acting. So this is 15. Okay, just remember this thing. This entire is 15. This entire is 20. Okay, and the students who participated in all the three competitions are 10. So now we have to see these three statements simultaneously, and accordingly we have to fill the number of students in the corresponding regions. Okay. So if you look carefully, so 10 number of students are there who participate in all the three. Okay. So total of these reasons were 20, right? So total 20 number of students are participating in both singing and acting. So here I have filled 10. So remaining 10 will be here, right? And for this reason, the intersection part for dancing and acting was 15, right? So 10 is already here. So 5 will be here, right? Now you can see for acting, total number of students are 50. Okay. So 10 plus 10 plus 5 we already have here, which is 25. Okay. So remaining 25 will be here in this region, right? Now we can see that in the question, it is given that 90 students have participated. Okay. So total we have 90. So now you can see that except this place, we have filled all the other places. Okay, so out of the 90, we can track these things like 15 plus 5 plus 10 plus 10 plus 25 plus 10. Okay, so that will be equal to what? 50, right? Did you understand this Venn diagram? So this will be 50.
Yes,
Okay, So if you understood this Venn diagram, now you can solve the question number 5. So you can see the question number 5 is, what is the probability that a student selected at random has participated in both singing and acting competitions? Okay, both singing and acting, but not in the dancing. Both singing and acting, but not in the dancing. So, so this will be 10 only, right? These 10 students. Uh, this part.
Yes, ma'am.
Both singing and acting, but not in the dancing. These 10 students are there who fall in this season, right? So the probability will be 10 divided by 90, right? Is it clear to everyone now?
Yes, ma'am.
Yes, ma'am. It's clear.
Okay. Any other question? Any other doubt from this speech? From practice assignment or from activity? No one has any doubt?
Ma'am, can you show me solution? I won't take screenshot.
Okay. So you just have to draw this Venn diagram carefully first, and then you can solve the questions. Okay, so
Yes, ma'am.
see in what reason the number of students according to the information given in the question.
Can you explain the question number 10 of the same activity?
Question number 10 of this. Question number 10 from where?
From 1, 7.1.
7.1, question number 10. Question number 10 is not there. Only 5 questions are there in 7 point. So you're asking for practice assignment 7.1 or
No,
activity.
practice assignment. Yeah, practice.
Oh, okay. Yeah. So here also solutions are given. Did you check it? Did you try to understand the solution?
Out by myself, so that's why I didn't check the solution.
Okay, I'll explain it. So here, in a particular game, the player needs to throw a dart onto a circular board whose radius is 8.5. Okay, the points allotted to the player are based on where the dart lands. So let R be the distance at which dart lands from the center of the board. Then points allotted are as follows. So now assume the player is not professional and there is an equal chance that the dart could land anywhere on the board. What is the probability that the points scored by the player in one throw is a multiple of 4? So multiple of 4, which means you can see also in the note, it is given that 0 is also a multiple of 4 here. So we have to take this point, okay, this one, then
Yeah.
this one,
The
4 and 8. Okay, so what we have to do, like whenever we have to calculate probability, the general formula is favorable events divided by total number of outcomes. Favorable outcomes divided by total number of outcomes. So here also we just have to find the region which is favorable for finding out this probability. Okay, so for multiple of 4, we have to take this region. R is greater than 8, and then R, where it is lying between 5 to 7. Okay, and then for 1 to 3. Okay, so in the solution, you can see. So the total outcome, which means we have to find the total region, total area of the circular board. So that will be, so area for a circle is pi r square, right? So R is given to us here, which is 8.5. So total area will be 8.5 square into pi, right? So this is something we have to put in the denominator part. Okay, now we have to find the area for the region, this one. Okay, so how can you find this region? So suppose the circular board is, so you have suppose this circular board, okay, and this radius is suppose 8.5. Okay, this is 8.5. Now, this is one small circle inside it. This is suppose another. Okay, now suppose this one is a 1, just suppose, and this one is 3. Okay, and R is between 1 to 3. Then how can you find the reason is this one. So we have to find the area of this region, right?
So we subtract the first minus the third minus the second, right?
Yeah,
So
so we
we
just have to like pi 3 square minus pi 1 square. Okay. So area of the big circle, this one, this circle, and the area of this circle. Okay, then you will be left with this area. Okay, so in this way, we are finding out the favorable reason for finding out the probability. So similarly, this is for 1 to 3. Similarly, you can find for 5 to 3, 3
yeah,
to 5.
now I got it. Yeah, now
Sorry,
I got it. So
yeah,
yeah,
5 to 7,
yeah,
sorry.
yeah. So you add these areas and then you divide the
Yes.
denominator would be the pi r square, the entire set.
Yeah.
Yep.
So there is a mistake in this question actually. They have not calculated this reason. So that will be corrected. Don't worry about that. So you have to include this area also, where R is greater than 8. Okay. Then you will
Okay, yes.
add those areas and divide by the total area.
Mhm. Okay. Okay. Thank you.
Yeah. Any other question? Anyone? And out from week 7? Please respond. If you have any question, you can ask. And no one has any doubt? Please ask your doubts in this session. Otherwise, you will be asking your doubt in some other session, which will be for other weeks. So it's good if you ask them now.
I mean, I have just a point of doubt in question number 12 of the same activity, same practice question,
Um,
assignment 7.1.
7.1. Okay.
Yeah. So here they say that all these four events are disjoint events, right? E1, E2, E3, and E4. And the probability of E2 and E4 are given, and
Which question?
probably
This one?
okay. Question number 7. Question number
Seven.
12. 12. 12. So, Yeah,
Yeah.
this is the right question. Yeah.
Hmm.
So so all these four probabilities should add up to one. That's right. And
Hmm.
you've been asked to to compute the probability of the union of these four events. Okay, this is one, and compute the probability of the event E1, and so E1 union E3, that would just be P of E1 plus P of E3, right?
Yes, in this case, because all these events are disjoint.
Disjoint events. Okay,
Okay.
exactly.
So for
Yeah,
disjoint events, probability of union of two events is equal to the summation of their individual probability. If they are disjoint, then
right.
only.
Yeah.
Otherwise, if
So
they are not disjoint, then you have to use the addition rule.
yeah, exactly. Because in there, the E1 intersection E3 would be zero. So that would be
Yes.
null set. Yeah.
Yeah. Nothing else? So have you all solved activity questions or not?
It's all, ma'am.
Okay. So all done. Any doubt? Any question?
No, ma'am.
Okay. Anyone? Anyone else who has doubt? No one has any question?
No, ma'am. I do not have any problem.
Okay. If no one has any question, then we can end this session. If you want to ask, then ask it now. Otherwise, I will close the session.
Hello, Miss.
Hello.
I have a question about the quiz 2 exam. Uh, how much do we have to score to be eligible for the enter?
Okay. So the eligibility criteria that will be sent to you via mail. I have to check it again. So wait for the email. You will be informed about that.
Ma'am, we
Okay.
have got the email, I guess.
Have you received the mail for the eligibility criteria?
Yes, the best out of seven, the best 5 out of 7.
Okay.
It
Okay.
should
So
be
if you
more
have,
than 40 and attendance in one of the quizzes.
okay. Yeah. So just go through this that mail. So it will be mentioned there.
Ma'am, what will be weightage of week 1 to 4 in quiz 2?
Week 1 to 4 will not be there in Q3.
No, only they will ask about week 5 to 8.
5:30. Yeah. Any other question?
Ma'am, I have no questions in practice assignment, but for greater understanding, can you solve questions, practice assignment questions one time?
So which question? Any particular question you want to ask?
Not particular questions, but if you can, all questions.
Not all the questions, but okay, solving few of the questions. Okay, let's start with the question number 1. So you can see the question is, in a horse race, 6 horses numbered from 1 to 6 are participating. Okay, which is the probability? What is the probability that all the even numbered horses complete the race at first, second, and third places? So did you try it first? What will be your approach?
Yeah, I'm trying, ma'am.
Okay, see. So in the solution also you can see that question is saying that all the even number horses complete the race at first, second, and third places. Okay. So total we have 6 horses. Okay. Suppose. Okay, this is first place, second place, third, fourth, fifth, and sixth. Okay. So according to the question, all the even number horses comes first, second, and third place. Right? Okay. So now you can see for even number, which means total we have 6 horses, which means second horse, fourth horse, or sixth horse. Okay. So these horses may occupy these places, these 3 places. So which means we just have to arrange these 3 horses into these 3 places. Okay, which we can do in 3 factorial ways, right? Now we are left with odd number horses, which are 1, 3, and 5. Okay, which we have to fill in these 3 places. That also can be done in 3 factorial ways. Okay, so the total number of ways will be 3 factorial into 3 factorial for this condition. Okay, where even number horses come first, second, and third position, and odd number of horses come at 4, 5, and 6 position. Okay, so this is like favorable outcomes divided by total number of outcomes, which means we have 6 horses that can be arranged in 6 factorial ways, right? So we have to divide it by 6 factorial. So this will be your probability. Okay, so now you can see here also. Okay, 6 factorial is the total number of ways, which is 720. Favorable will be 3 factorial into 3 factorial. So when you divide it, you will get 0.05. Is it clear to you now?
Yes, ma'am.
Okay, now the next question is that Nandini's phone battery uh, dies as she is driving to her hometown. She knows that there are 2 4-ways junction before reaching her hometown. So she drives on until she reaches a 4-way junction and arbitrarily chooses one way in front of her. Okay, so she has 2 4-ways. Okay, and arbitrarily she can take any of the way. Okay, so at the next 4-way junction, she again randomly chooses one of the ways in front of her. So now we have to find what is the probability that Nandini will reach her hometown without having head back. So you can see. So suppose this is one 4-way. Okay, so suppose she is coming in this way So now she has three options to choose from, right? These three. So here she has three options. Again, she like another four ways there. Okay. So maybe if she is taking this path, again she has three options to choose, right? Again, she has three options. The total options she has is 3 into 3, which is 9. Okay. Now, out of these 9 options, 9 ways, only one way will be correct to reach her hometown. Okay. So, out of 9, only one is the correct option. So, the probability will be 1 by 9. Okay. You can see this thing in the given solution also. Okay. Now, let's take this question. So, here probability of C is given. Probability of A union B is 0.6. And probability of A union B union C is given as 0.8. You have to find this one. Okay. So probability of C is 0.3. Probability of A union B is given. And probability of A union B union C is given. So A union B is 0.6, 0.8. This is 0.6 and 0.8. We have to find probability A union B intersection C. Okay. You can see this thing we have to find probability of A union B intersection C. Okay, so if you remember the addition rule, so probability of A union B union C. Okay, now what we can do here, we can consider A union B as a different event, as one event. Okay, so now probability of A union B plus probability of C minus probability of A union B intersection C, right? Is this statement clear to you? Okay, I have just applied the addition rule here. Is this clear to everyone? Anyone has any doubt in this part?
Clear, ma'am.
Okay, so this thing we are given. Okay, probability of A union B union C is given, which is 0.8. Okay, and A union B is also given. Hello, yes.
Ma'am, once again explain the question, ma'am.
The question is, we are given these information with us. Okay, probability of C is 0.3, probability of A union B is 0.6, and probability of A union B union C is 0.8. We have to find this thing. Probability of A union B intersection C. Okay, so we can just apply the addition rule. So according to the addition rule, if you have suppose two event E and F, okay, so how will you find probability of E union F? It will be probability of E plus probability of F minus probability of E intersection F. Okay, so consider, suppose here that A union B is equal to E. Now you have to apply this formula for E union C, suppose. So this is what? Probability of E, then probability of C, then E intersection C. Now this formula is clear to everyone?
Yes, ma'am.
Okay. Now just put all the values. So this is 0.8. A union B is 0.6. And probability of C is 0.3. Okay. And this one we have to find. Okay. So now you just have to do some simple calculation and you will get the answer. Okay, so it will be 0.6 plus 0.3 minus 0.8. Okay, is it clear to everyone? Any other question which you would like to ask? Okay, let's take this question. So, which one of the following statements are true? We have to find this one. Okay, first option is probability of A union B union C complement is equal to the probability of A complement intersection B complement intersection C complements. So, is this statement correct or wrong?
Yes, it's correct, right?
Yeah, it is correct. Because if you see A union B union C, we have to find the complement of this event. Okay, so what A union B union C tells you, which means that either A or B or C occurring. Okay, the complement of this event will be giving you that neither of these events occurs. Okay, which means A complement. Okay, A also is not occurring, and B also is not occurring, and C also is not occurring. Okay. Now, next option is that probability of A intersection phi is equal to 0. So, what will be A intersection phi only? If I talk about this set only, A intersection phi, what will be this value? Suppose A is any set and phi is null set. Okay, then what will be this value?
0.
A intersection phi.
It's a null set, right?
Yeah, phi is the null set. A is some set which contains some element, suppose. So it will be phi only. It will not be 0 because 0 is also an element. Okay, so it will be phi because there is no element in common. In null set, we don't have any element. Okay, so no element common in A and phi. So it will be phi. Now, if you take probability at both sides, so it will be probability A intersection phi. And here it will be probability of phi. So probability of null set is 0, right? So probability of A intersection phi will also be 0. Okay. Now next is probability of A union phi. So if I take this set, A union phi, what it will be?
A.
It will be A. Okay. Now you just take probability at both sides. So that will be probability A. Right? Now we have to see the last part of it. So it is probability of A complement union B union C, which is equal to this part. Okay, so now let's take the left hand side. So it is probability of A complement union B union C. So if I simply apply the addition rule, it will be probability of A complement plus probability of B plus probability of C. Okay, minus probability of A complement intersection B. Okay, like these two events, then these two, and then these two events. Okay, in this way, we have to take the intersection path. Okay, minus probability of B intersection C minus probability of A complement intersection C. And then we just have to add the intersection part of all these three, which will be probability of A complements intersection B intersection C. So this is the addition rule for three events. Okay, so this is a rule for when we have two events. Okay, and when we have three events, then we can use this formula. Okay, now one more thing you should remember, that if you have probability of A complement intersection B, so that is equal to the probability of B minus probability of A intersection B. Okay, and probability of A complement intersection C, that will be equal to probability of C minus probability of A intersection C. Now you can see this formula in the Venn diagram also. Okay, so if I draw the Venn diagram of it. So for first one, I am drawing A and B. So we have this A and B. So in A complement intersection B, so A complement intersection B will be this part, right? Is it correct or not?
Yes, ma'am.
Okay. So now we have to verify that whether right hand side is equal to this or not. So according to the right hand side, you can see we have to subtract intersection part from B. So if I draw it separately, then you can see you have this entire B. Okay, you have this entire B. And then what you have to do, you just have to subtract A intersection B part. Okay, so A intersection B is this region, right? So you just have to remove this part. Okay, so it will be this part only again. You can see out of B, we just have subtracted A intersection B. Okay, now can you understand this formula? Is it clear
Yes,
to
ma'am.
everyone, these two statements?
Yes.
Okay,
Yes, ma'am.
now we just have to put these values here. Okay, so probability A complement union B union C. Okay, so probability of A complement first. Okay, then probability of B plus probability of C. Now at this place, from minus probability of A complement intersection B, we can write this thing. Okay, so it will be minus probability B, and it will be minus minus plus probability A intersection B. Similarly, we can do for A and C also, right? Okay, first we have B intersection C. So minus probability B intersection C. Now at this place, okay, we have to write this formula. So it will be minus probability C and plus probability A intersection C. Okay, now we have this one. Probability A complement intersection B intersection C. So in this also we can apply the same formula. Okay, so just see that probability A complement intersection B intersection C. Okay, so if you see these formula carefully, what we are doing from this part, okay, if we have A complement intersection C, so from B, you have to remove the intersection part of A and B, right? If you see this formula from C, okay, you have C here, and you have to subtract the intersection part of A and C. So similarly, you can apply this formula here also. Okay, so it will be probability of B intersection C minus probability of A intersection B intersection C. Do you understand this formula? Last third one.
Yes, ma'am.
Yes, ma'am.
Okay.
Yeah, it follows in first one. Yeah.
Yeah. Similarly, I have written this one. Okay, now I can put this value also. Okay, so at place of A complement intersection B intersection C, I will write this part. Okay, So it will be plus probability of B intersection C, okay, minus probability A intersection B intersection C. So now we can see that these two terms will be cancelled out, right? Is it clear to everyone? Now we can write, so probability of A complement, we can write it as 1 minus probability of A also, right? Also, you can see probability of B cancels out and this term also cancel. Okay, we are left with only these terms. This one, and this one. So just write these terms here. Okay, so plus probability of A intersection B plus probability of A intersection C and minus probability of A intersection B intersection C. Now you can verify that the right hand side given in the question is same or not. Okay, these two are same. 1 minus probability of A, that A intersection B, A intersection C, and minus intersection of all the three. You can see here. A intersection B first, then A intersection C, and then intersection of all the three. Is this question clear?
Yes, ma'am.
So whenever you have these type of questions, you can just draw the Venn diagram and it will be easy for you then. Any other question you want me to solve? This one you have discussed already. This one is very obvious that if the intersection of two events is under set, then two events will be disjoint or mutually exclusive. These two are same. This one is also very easy, that 150 employees are working in an NPTEL office. 80 of them bring tea, 90 of them bring coffee. Okay, so some of them may drink both, but every person drinks at least one of these two beverages. So what is the probability that a person chosen at random from this population drinks both tea and coffee? So basically we have to find the intersection part here. Both tea and coffee, which means if A is for tea and B is for coffee, then we have to find the probability of A intersection B. Okay, so we need to find the intersection part first. So you can see that we have total 150 employees. Okay, out of them 80 drinks tea and 90 drinks coffee. Okay, so 80 plus 90, then we will subtract the total number of employees and you will be left with the intersection part of tea and coffee. Okay, so 20 will be the favorable number of outcomes divided by total outcomes. Okay, so that will be your answer. So if you want to represent it in the Venn diagram, you can see that for tea we have 80% and for coffee we have 90%, 90 employees. Okay, so you can see that 60 plus 20. Okay, so 60 plus 20, which is equal to 80. So 80 is for tea and this 20 plus 70. Okay, so this is for coffee. And 20 number of employees are common for both uh, coffee and tea.
Ma'am,
Hmm.
ma'am, question number 9, please. Explain, please. Question number 9.
Question number 9 is, in an exam, there are 10 multiple select questions. Okay. In each multiple select question, more than one options could be correct. 4 options are there. If a student chooses all the correct options, then he or she gets 4 marks for that question. Else, they will not get any marks for that question. So what is the probability that he or she will score at least 16 marks in that exam? So for at least 16 marks, they have to solve at least 4 questions, right? At least 4 questions correctly, right? So we have to find that they have the probability that they score at least 16 marks. Okay, which means either the student solves 4 questions correctly, or 5, or 6, or 7 in this way, or we can find this part by taking 1 minus complement of it. So 1 minus probability that the student solves 0 question, or 1 question, or 3 question correctly, right? So basically, these type of questions are done using binomial distribution, which you will be studying in further weeks. So the formula for that is something like, here we find the probability of x, like n, choose x, okay, p to the power x, and 1 minus p to the power n minus x, okay, where n is the total number of trials, okay, and x is the probability at the point at which you have to find the probability, and p is the probability of success. Okay, 1 minus p will be denoting the probability of failure in that case. So here what we have to find, that we have to find this probability that x is greater than 4. Greater than or equal to 4 it will be. So we can find this probability in this way also, 1 minus probability x is less than 4, right? So in this way, we just have to find 1 minus probability. It will start from 0, because either student will solve no question correctly, so it will be 0. Then we have to find for 1, then for 2, and then for 3. So what, how we can find these probabilities is that 1 minus, okay, so we just have to put these values into this formula. So n is 10, okay, because we have total 10 questions in the exam. So it will be 10, p 0, x is 0. See this formula again. Here x, and we have the value of x is 0 here, okay. And now we have to find the value of p. Okay, so p is denoting the probability of success. So we can see here. So we have MSQ type of question where 4 options are there. Okay, so either person will be selecting one option only, okay, or he or she will be selecting 2 options, or 3 options, or all the 4 options. Now we have to see in how many ways a student can select one option. So that can be done like 4C1 ways, right? Out of 4 options, we have to select only one. So that we can do in 4 ways. Now, if person or the student selects 2 options, so how many ways we can select 2 things or 2 options out of the 4 options? That can be done in 4C2 ways. Okay. Now, if we have to select 3 options, that can be done in 4C3 ways. Okay. That will be 4C4 actually here. Okay. Now we have to select all the 4 options. So that can be done only one way only, right? Out of all the 4 options, we have to select 4 options only. So that can be done in one way only. So now you can see, if you add 4 plus 6 plus 4 plus 1, that will be 15. which means that you can attempt one question in 15 different ways, right? For one question, you have 15 ways. And out of these 15 ways, only one way will be there, which is the correct, which will be giving you the correct answer for that question. Okay. So you can see out of the 15, only one option will be correct. So total we have 15 options. Okay. You can see if you find the probability of success P, total we have 15 options. Out of them, only one is correct option. So probability of success or probability of doing the question correctly, that will be 1 by 15. And 1 minus P will be 1 minus 1 divided by 15, which will be 15 divided by, sorry, 14 divided by 15. Okay. Or you can say that the number of the probability of doing a question wrongly, it will be 14 divided by 15. Okay. In 14 ways, you can attempt the question in a wrong way, right? So now we just put the values. So P is 1 by 15. So 1 by 15 to the power 0. Okay. And 1 minus P, which is 14 divided by 15 to the power 10 minus x, which means 10 minus 0. Okay, that will be equal to 10 only. Similarly, you have to find for 1. So it will be 10C1, 1 by 15 to the power 1 and 14 divided by 15 to the power 10 minus 1. Similarly, you have to find it for 2 and 3 also. Are you understanding these parts?
Yes, ma'am.
Okay. So don't worry about this binomial distribution. You will be studying it in the further weeks. Okay. Okay, in this way, you can find this probability. Now, is it clear?
Yes, ma'am.
Any other question? Anyone else having any doubt? Okay, then we can end the session. So I am supposing that no one has any doubt. Okay, so, and I am ending the session then. Okay, thank you everyone.
Thank you, ma'am.